What's up guys, this is Masi, welcome to my channel. This video I want to talk about acids and bases. I got this material from book called Chemistry by Zumdahl and it's from chapter 14. I start with nature of acids and bases and let's see the definition for acids and bases. Acids were first recognized as a class of substances that taste sour, like vinegar tastes sour because it is a dilute solution of acetic acid, and citric acid also responsible for the sour taste of a lemon. So the first person was Arrhenius to recognize the essential nature of acids and bases, and he postulated that acids produce hydrogen ion in aqueous solution while bases produce hydroxide ions. So acids produce hydrogen ion and bases produce hydroxide ions. So hydroxide is negative and hydrogen ions are positive. We also call it hydronium. Hydronium when it's surrounded with water molecules, or we also call it proton or H+. Hydrogen has one electron and one proton and there is no neutron. So when hydrogen loses one of the electrons, actually it has only one electron, it has no electron but it has only one proton. So that's why when hydrogen loses the electron we call it a proton. So H+, we call it a proton. What are the limitations of Arrhenius concept? Arrhenius concept is limited because it applies only to aqueous solution and allows for only one kind of base, which produces hydroxide ion. So basically Arrhenius concept is only related to those bases that when it dissolves in water it produces hydroxide ion. Some of the bases that do not produce hydroxide ion is out of the scope for Arrhenius concept. So that's why we have another definition by acids and bases produced by Bronsted-Lowry. A more general definition of acids and bases was suggested by the Danish chemist Bronsted and the English chemist Lowry, and they said acid is the proton donor, H+ donor, and base is the proton acceptor. So if we go back to Arrhenius was saying that when acid dissolves in water, it dissociates into its component and produces proton, and base, when it dissolves in water, it produces hydroxide ion. And since it had some limitations, Bronsted-Lowry defined a new concept for acids and bases, and they said acid is the proton donor and base is the proton acceptor. So if we see the general acid-base reaction, we have Ha plus H2O, it gives us H3O plus and A minus. So the first two are the reactants, acids, and in this case water is the base. When they react, acid is proton donor, it gives the proton H plus to water, so water becomes H3O plus, and acid will be A minus because it lost proton. So acid becomes A minus, which we call it conjugate base, and water, it accepts proton, so that acts as a base in this case, so it becomes H3O plus, and we call it conjugate acid. So acids and bases after reaction will become conjugate acids and conjugate base. Acid becomes conjugate base, base becomes conjugate acid. So what is conjugate base? Conjugate base is everything that remains after acid molecule lost the proton. So it's everything that remains of the acid molecule after proton is lost. On the other hand, conjugate acid is formed when the proton is transferred to the base. So after base gain that proton, it will be conjugate acid. It means that it has the ability, or it has the affinity to lose the proton. That's why it's called conjugate acid. That's why it's called acid. So since it got the proton, it has the ability to lose that proton. And then we have conjugate acid-base pair. A conjugate acid-base pair consists of two substances relate to each other by the donating and accepting of a single proton. So as I said earlier, acid becomes conjugate base and base becomes conjugate acid. Thank you for watching. Please leave me a comment if you have any question and I'll get back to you as soon as possible. Have a great day.